we can do a little recording on this. So slope fields. Basically what slope fields are is we're going to take a differential equation like this first one, and we're going to go to each coordinate, plug in the x and y coordinate at that spot into the differential equation, and then we're going to sketch the slope that we get out of that, because that's what a differential equation like this gives us. So for instance, let's start at this point. I'm going to assume this point is 0, 1. So I'm going to plug in 0 for x and 0 or 1 for y into this differential equation, which I'm only really plugging in 0 for x, which gives me 1. So at this spot, I'm going to draw a slope of 1. This spot is this point 0, 2. So I'm going to plug in 0 for x, 2 for y. And then whatever that gives me, which in this case is 1, I'm going to draw a slope of 1. Right here, 0, 0. Plug in 0 for x, plug in 0 for y. I get a slope of 1. Now I'm going to move over here to this coordinate, 1, 0. Plug in 1 for x, plug in 0 for y, I get a slope of 2.
Very good.
So as I'm starting to do this, there's a couple things I want to point out. But look, this one is steeper than this one. Oh, well, let's see what happens at this point. -1, 0. I plug in -1 for x, 0 for y, I get a slope of 0. Let's keep going along the x-axis. -2, 0. I plug in -2 for x, 0 for y, I get -1. Yes. In case you didn't hear that comment, the question was, do we do this for all the points on here? Yes. Yes, you do. So that is the first page of Slope Fields worksheet. Is you take the differential equation given to you up here, take each of these coordinates, assume they're integers, positive integers, or I'm sorry, assume they're integers, positive or negative, wherever they're at. Plug the x and y coordinates in and sketch the approximate slope. Now, I like to obfuscate this a little bit, but I'm just going to cut straight to the point. I don't care. I'm not going to be taking out a little protractor and measuring, oh, they drew a slope of 1.67 instead of a slope of 2. All wrong. I don't care. I care more that you're showing that it's positive, 0, or negative, and showing approximate increases in slope. Okay? Like this should look a little steeper than this one, because this has a slope of 1, this has a slope of 2. This one, if I kept going, has a slope of 3, slope of 4. What we do, once we finish filling out a slope field, like I can just finish this one real quick because I know what this one's gonna look like. Horizontal, 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 negative. Oh, that was bad. Let's go a little higher. Oh, that looks really bad. Whatever. Don't tell me what to do. That's what happens when I go quick.
This is looking great. I'm pretty touched.
Oh man, look at, damn, that was terrible. It's still good. It's still good.
It's still fun.
Homer, it's gone. I know. All right, I can keep going. And these are all just like, oh. These are not vertical. These are just big slopes, and I'm have less control over my motor function with a mouse than you do with a writing utensil. So we just finished filling this one out. What the slope field shows you are possible solutions to this differential equation. In section 5.6 and 5.7, we solve differential equations. So like if we want to solve this one, we'd multiply by dx, integrate, and in this case, we would get y equals x 1/2 x squared plus x plus c. If you were to let me take a different color. I was going to just pick a point and start tracing. Just kind of following the slopes I find, no matter how bad I am at following them. The thing I just drew, following the slopes, looks like a parabola. And that is a solution. It's a specific solution to that slope field, to that differential equation. So that's what's nice about slope fields, is you can visualize what a solution to the differential equation looks like. All right. So that's what you're doing on the rest of the front page. You don't have to draw in this like a particular solution, but if you're trying to visualize what the hell does it look like, there you go. That's what it looks like.
Mr. Watts,
Yeah.
are all the columns always the same slope, or like all of the rows based on this X and Y equation?
If it's only X or only Y, you're going to get either columns that are all the same or rows that are all the same.
So like for 2, all the rows are going to be the same slope?
Correct. So just to recap that, like for number 2, as Tessa said, just in case you didn't hear, all the rows are going to have the same slope. So that works out really nicely when it's only X or only Y. Number 3, you can see is X plus Y. Again, as you start going through that, you'll start seeing patterns. You can kind of go from there. Okay. But that's basically what slope fields are. Our book doesn't use the word slope fields. They keep throwing in a bunch of things like slope fields throughout the book. Technically, it's been in like 3 or 4 different chapters, but they never really tell you it's a slope field. They're just like, oh, look at this thing, and move on, no context. But this is a slope field. Okay, so the front side, you have 6 of these to do. The back side is matching. What you're doing on the back side, let me erase this. All right, I'm going to clear it in 5, 4, 3, 2, 1. Close annotation. The second page, you have a bunch of differential equations here, like a bunch of their slope fields. You have to match them up with their possible solutions. So like for number 7, which one of these could be y equals 1? Right? Match each slope field with the equation the slope field could represent. All right, so match it up with which one it looks like. Which one of these looks like it could be y equals 1? D. Because y equals 1 is a constant function, which means it's just a horizontal line. So look at that. Number 7 on the back side is D. So that is today's assignment. That's it. And there's more, but that's only if you're looking at the digital copy and not the one I printed out for you. I only really care about page 1 and page 2. So what questions do you have about slope fields before I stop recording?
I'm just a little confused as to how you plug in the coordinates for the first side in the dy dx equation.
Got it. So is there one in particular you're thinking about?
Just try on the second, or doing the second one.
Okay.
You don't have to draw,
Just talk through it?
Yeah.
Okay, so like for number 2, for dy dx equals 2y. So I'm going to pick a coordinate and assume it has integer values.
Yep.
So like, I'm going to pick this one right here.
Okay.
That coordinate should be, let's see, -1, +1.
Yep.
All right. So I'm going to take the x and y coordinates of that spot, of that coordinate,
Yep.
and plug those values into the differential equation. Notice this differential equation only has y in it, so I really only care about the y coordinate of this spot.
Okay, so you don't have to.
I think the other side stays the same.
Oh, really?
Yeah.
Well, they're going to just tiny slope at a point, so you're saying that slope is each of that.
Okay.
Yeah, and if you do enough slopes at random points, you get the general shape of the original function.
Yeah. Okay.
This one looks
that
better
makes more
than
sense.
blue.
And then, okay, so I guess for 3, then you just combine the coordinates and just basically add them together then?
Yep.
Oh.
So like at
okay.
this point, at the same, choosing the same one, at -1, +1,
It'd just be 0.
it'd be 0. So you just draw the horizontal line.
Holy cow.
Yep.
So we don't have to deal with any derivative stuff, it's just coordinates.
Yeah,
Oh, that's nice.
because basically what you do, you already have the derivative, and by sketching the derivative at a variety of points, you can just see what the antiderivative of it could be.
Okay,
That's the idea of the slope field.
cool. I like
We
that.
sketch the derivative at a bunch of points to see what the antiderivative could be.
Is there answer key online?
No, I don't have an answer key for this one. There might be somewhere if you search long and hard enough, but
I would just assume I got them all right.
yeah, as long as you can add or subtract and multiply a little bit.
Potentially not.
Yeah. Ooh, there's one thing I want to talk about in number 6. So in number 6, see, look at that. It's negative y over x. When x equals 0, don't draw anything because it would be undefined at that spot. Don't draw a vertical line, just leave it blank. So all along the y-axis here, leave it blank. Whenever you're dividing by 0, just leave it blank.
Oh, because it's like showing a asymptote there.
Yeah. So just don't put it in. Exactly. And comment in the chat was like, it's kind of like reverse backwards tangent. Yeah. Basically, like normally we take like a function and get a tangent line from it. Now we're saying, here's a tangent line. Here's like 70 tangent lines. Oh, the original function could look like this because of the tangent lines. Boom. Cool. Wonderful questions and thoughts and ideas. What other questions, thoughts, or ideas do you have before I stop recording? Cool.